Let's see, we've been graphing trig functions, and last week we graphed sine and cosine. Here's the basic shapes. Little graph here sort of summarizes the graph of y equals sine x. It tells us stuff like the domain is negative infinity to positive infinity. Remember, that's a word you may not have heard a lot of since college algebra. The domain refers to the x values. This graph keeps repeating and repeating. Would it eventually hit the left wall and the right wall? Yeah, so the domain is all real numbers. Range refers to the y values, and here the y values are bouncing between -1 and 1. That's why it says the range is -1 to 1. And with that interval notation, that square bracket means including 1 and -1. And we can look at the graph of cosine. Again, it's domain all real numbers. It's bouncing between -1 and 1. That's what we did a week ago today. Then on Wednesday, we were graphing tangent and cotangent. Okay. And the key to graphing tangent and cotangent is to know where the heck those asymptotes occur. And so here, look how formally they say it. For the domain, x can't be that 2n plus 1 is, if you let n be an integer, if n were, say, 0, we'd have 1 pi over 2, and just keep going. We'd graphed them from -pi over 2 to pi over 2, and this 2n plus 1 is just a fancy way of writing odd multiples of pi over 2. Like the next asymptote would be at 3 pi over 2, 5 pi over 2, and so forth. The key to graphing this is to remember to take the angle and set it between -pi over 2 and pi over 2. That's how you find those asymptotes. With cotangent, at 0 and pi, and you just keep going on, 2 pi, 3 pi, 4 pi, 5 pi. The asymptotes, x can't be a multiple of pi. And so you would take the angle, set it between 0 and pi, and that's what we did the last time. And today we're going to be graphing secant and cosecant. And the key to graphing secant and cosecant curves are to be able to graph the corresponding sine or cosine. To graph y equal cosecant x, let me see. Let me find a different color. What you're going to do first is graph y equals sine x. Now realize this graph here has 2 periods showing. Usually when I'm doing these, I only graph 1 period. So this red curve is y equals sine x. And once you have the sine curve drawn, the vertical asymptotes are going to be wherever the graph crosses the x-axis. So you'll draw vertical asymptotes. Those are the vertical lines the graph can't cross. Wherever the graph of y equals sine x crosses the x-axis. And then you just draw the reciprocal curves. Those are the U-shaped curves. What you're saying is, okay, notice right here there's a point in common. That y value 1. What you're saying is, okay, the reciprocal of 1 is 1. But what if we start taking the reciprocal of, say, like, does it look like I'm pointing at 1/2? Right there, this y value right here might be 1/2. What's the reciprocal of 1/2? About 2. You see, notice how it goes up. As these numbers here, out here, get closer and closer to 0, like this is up 1/10, the reciprocal of 1 over 10 would be 10 over 1. And so these values are going up more and more. And the same thing down here. The reciprocal of negative 1/2 is negative 2. The reciprocal of negative 10 is, of 1 over 10, negative 1 over 10 is negative 10, and so forth. Boy, I'm saying that poorly today. So we just sort of have to see how to graph these. But the secret to graphing cosecant or secant is to first graph the corresponding reciprocal function. If you want to graph secant, you first graph cosecant. I'm doing this in red. Then you draw the vertical asymptotes where the graph crosses the x-axis, and then you draw the little U-shaped curves. Those are the reciprocal curves. Let's do one that isn't already drawn for us. Okay? I think I'm going to graph then we'll start looking at the homework. First, I'm going to graph. Let's graph y equals 2 secant 2x minus pi over 2. The graph y equals 2 secant 2x minus pi over 2. What you're going to have to be able to do first is graph the reciprocal curve. What's the reciprocal of secant?
Cosine.
Yeah, so just replace secant with cosine. So we're graphing 2 cosine 2x minus pi over 2. Now, sine and cosine have amplitude defined. Everything else, tangent, cotangent, cosecant, secant, those the amplitude isn't defined. So I'm about to write amplitude, and I'm talking about the green cosine curve I've written here. The amplitude would be 2. So it's going to be bouncing between 2 and negative 2. And do you remember how we found where the graphs start and stop for sine and cosine? You take the angle, 2x minus pi over 2, and set it between what two numbers? Do you remember? 0 and 2 pi? Oh gosh, how do I want to go about this? I think I'm going to work. If you want to not work with the fractions, you can multiply straight through by 2, but I think I'm going to go ahead and work with the fraction. I'm going to add pi over 2 all the way through. So 0 plus pi over 2 is just pi over 2. Trying to get the x by itself in the middle. That 2 pi, would we think of that as 4 pi over 2 plus 1 pi over 2? Is that going to be a 5 pi over 2? Follow my calculations there? And now one more thing to do to get the x completely by itself. But if I multiply by half, would that do it? So we would have a pi over 4, and over here what would we have? 5 pi over 4? So this graph graphing y equals 2 cosine all of that. And I guess it's just tailor-made for me to just use one little block as pi over 4. So 1, 2, 3, 4, 5 pi over 4. Amplitude is 2, so it's bouncing between 2 and negative 2. Oh, let me lift this up. So this is cosine. Is cosine the one that starts up at the top, or does it start on the x-axis? Yeah, so it starts right here. I'm going to plot 1. Now midway through, it'll be there all the way down. So 1, 2, 3. So here's one period of y equals 2 cosine 2x minus pi over 2. That's not the thing we're graphing. We're graphing the reciprocal curve, y equals 2 secant. So to get secant out of this, wherever the graph crosses the x-axis, that's where you draw your vertical asymptote. So right out here. And then you draw the little U-shaped curves. It starts here. So what I'm about to draw in black, these are the graphs of secant. Goes like that. And it just runs beside that vertical asymptote. It doesn't touch or cross it. Start here, go up. What about like this? Now, can y'all tell the difference between the green and the black? The green stuff is not the graph of secant, it's the graph of cosine. So the answer here, these little half U-shaped curve here, this, and the vertical asymptotes. For my math lab, sometimes they'll show the vertical asymptotes, sometimes they won't. When you're doing these online, or actually online, you might want to be clicking the magnifying glass to get them to blow up and look better. But I printed out the assignment before class, and so it's going to look sort of, well, they're sort of hard to tell. But, oh, let me unmagnify that. So there it is, graphing secant. How would it differ if this had been cosecant? Well, instead of
sine instead of cosine.
Yeah, you'd use sine instead of cosine. Otherwise, it's that same procedure. Okay? Any questions there?